Okay, today we're going to be talking about transformations of square and cube root functions and talking about radical operations, so adding, subtracting, multiplying, dividing these guys. First part is taken straight from our textbook, which you haven't seen, but a good idea as you're doing these notes is go ahead and try and answer the questions before listening to the video and see what you get. It's much more interesting that way. Okay, so if we're looking at our transformation equation of a square root or a cube root function, what does a cause to happen? And this is similar to all our other function families. If the absolute value of a is greater than 1, we get a vertical stretch. If the absolute value of a is less than 1, so it's a fraction, we get a vertical compression. If a is less than 0, what happens to our function? Just like all the other function families, this caused a reflection vertically. So remember, it just flips over that x-axis. How about for values of d? What does that cause to happen? D causes it to move up if d is greater than 0, or down if d is less than 0. Again, the same thing we've seen in previous function families. How about for c? If c itself is positive, we move to the right. If c is less than 0, we translate to the left. And again, remember, the equation will look different. So if c had the value of 3, the equation would be the square root of x minus 3, because the minus is part of the equation. Okay, how about for values of b? Let's come back and take a look at this. If the absolute value of b is greater than 1, we have a horizontal compression by the value of 1 over b. If the absolute value of b is less than 1, we get a horizontal stretch by the value of 1 over b. And in this case, because it's a fraction, we'd have to take the reciprocal of that. So that really is equal to b. So the horizontal stretch is by the value of, well, let's use an example. If b was 1/2, the horizontal stretch would be 1 over 1/2, which equals 2. And finally, we haven't investigated this before, but if b is less than 0, so if b is negative, we get a horizontal reflection. So this meant it reflected across your y-axis. So this is the first time we've seen this before. Okay, let's flip this over. And sorry for the copies. I had some errors creating this, obviously. Okay, so we're going to start with our square root function, and the domain is limited to 0 to 14 to begin with. And we've moved this wave over to the right. Now, if we want to shift to the right, where do we need to show that shift? Is it inside the function or outside of it? And it's going to be on the inside, because the shift is horizontal, not vertical. And what values do we have to change to make this shift to the right? And we change the c value. And again, c controls the right and left translations. Okay, let's take a look. Let's write the domain of each transformed function. Okay, so again, we're not allowing our functions to go off the page here. we're saying they actually end at this point, and that value is 14. So let's take a look. Our new functions, we have g of x. So its domain goes from 4 is less than or equal to x is less than or equal to 14. H of x, the domain goes from 8 to 14. And I'm writing this in the interval notation, and I use the brackets because 8 and 14 are both included. And my final one, k of x, which has been shifted over by 12, its domain is from 12 to 14. Okay, so question 5. We've got 3 students who have tried to create the equations for g, h, and k. Let's decide if they're correct or not. So Devin's equation, he subtracted 4 from the function, which would be the square root of x minus 4. Not correct. And why this is not correct? Because this would cause it to move down 4, which is not what we wanted. Stewart said he subtracted 8 inside the function, so the resulting function in terms of x is the square root of x minus 8. That is correct. That would cause it to move 8 to the right, which is what we have graphed. The final one says f of x, we added 12. Well, it certainly moved over 12, but this says this is not correct, because if the equation says plus 12, it has actually moved left 12, which is not correct. Okay. So again, we needed horizontal translations to be inside the function, but if we move to the right, the c value is positive, so the equation is negative. Okay, so let's look at our transformational functions. Our original function was the square root of x, and that domain was from 0 to, let's get back on the camera. And we use the brackets because 0 and 14 are both included. G of x moved over by 4. So I took my g, and I have x, I took my original function f and subtracted 4. So that was x minus 4. My domain was from 4 to 14. To get h of x, I took f of x and I subtracted 8. So the function said x minus 8. And our resulting domain for h of x is its graph from 8 to 14. K of x, we took f of x and subtracted 12 to move it to the right by 12. So the actual function looks like that. Our domain is very small. It only goes from 12 to 14. Okay, so now we want to look at this, and what is it they're asking us to do? They want us to move our functions, or to reflect them, it looks like. Okay, so we want to reflect these across the line x equals c. So each one will be different. Okay, so f prime, that means it's associated with f. Okay, so g of x, let's take a look at g of x. G of x has been shifted to the right by 4, but we now need to reflect it to the left. So when we reflect it, you get that. So we're reflecting over the line x equals 4. Oops, let's zoom out so you can actually see what I'm doing here. Okay, there's g of x. To get h of x had been shifted by 4 more, so it was shifted by 8. But I want, instead of drawing it to the right, I want to reflect it to this side. So that reflects, so this is h prime of x. And again, the prime just tells us it's associated with h of x. And our last one, k of x had been shifted by 12. Let's see, this comes over, it looks something like that. K prime of x. Describe how we use the transformation equation to determine it. Let's see, so we needed to do a reflection across x equals c. So if we want to reflect horizontally, we change b. And the way we change that is you multiply b by -1. So we need the opposite value of b to have this reflection. Okay. How did the domain of each one of these change? So our domain, it looked the opposite. Let me put this back up here. If we were looking at this, g of x goes from 0 to 4. The original g went from 4 up to 14. So it looks like our domains have changed. They become the opposite. So domains are opposite. For example, g of x, the domain was from 4 to 14. Now, g prime of x is from 0 to 4. So we've flipped our domains. Why does the graph only show 3 curves? I have to think about this. Think about our original function, f of x. If I reflect that across x equals 0, let's see. So there's my original one. If I reflect across x equals 0, it looks like that. However, I am only looking at this from 0 to 14. So I don't see this. So that's why that curve has disappeared. It's reflected completely into the other quadrant. Okay, so 7. Suppose the students wanted to reflect our 3 new waves, g prime, h prime, and k prime, across the line y equals 0. So if we're reflecting across the line y equals 0, this is a vertical reflection. Describe how we would use this. We would simply multiply a by -1. We've gotten very good at that. So write these 3 new functions to represent the reflections of our prime, g prime, h prime, and k prime, and then in terms of x. Use the double prime symbol to indicate them. Okay, so g prime of x, we took the negative of g prime of x, and what that function looked like, we put a negative in front of the square root of negative x plus 4. The domain of this is 0 is less than or equal to x is less than or equal to 4. Okay, there we go. Okay, let's take a look at h double prime of x. So that means we take the negative of h prime of x. So all we're doing is taking the negative of negative x plus 8. And again, remember, this was the one that was reflected horizontally. So we've got 0 is less than or equal to x is less than or equal to 8. And our final one, we've got k double prime of x is equal to negative k prime of x. So negative square root negative x plus 12 with a domain of 0 is less than or equal to x is less than or equal to 12. Okay, very good. And actually, let's back up a second. I don't think I put this on here, but I didn't write down how we found f prime. So f prime of x, we said we had to change b to be negative. So this is equal to f of negative x, which is the square root of negative x. So you don't need that. G prime of x, sorry I'm doing this in the wrong order, is equal to g of negative x, which is negative x plus 4, negative x minus 4, which is equal to a negative x plus 4 there. Because originally we had x minus 4 to move it to the right by 4. And h prime of x is equal to h of negative x. So that equals negative x minus 12. If we distribute that negative, we get negative x plus 12. Okay, so let's come over to problem 8. We want to add some more waves. Of course we do. Of course we want more waves on our graph. Okay, so we want copies of g prime. So here's g. Let's just look at that. There's g. The copies should be the same except we want it to be half as high. So we want to compress them if they're half as high, and they need to shift to the left by 2 units. So there's g. This is our new one. We want to call this one q of x. So q of x, let's see. To get q of x, I'm going to take g prime of x, but I have to shrink it by 1/2. So that's my a value is going to be 1/2 of g of x. So 1/2 of g prime of x, and I need to shift to the left by 2, so I should put a plus 2 there. Okay, so that's what that would look like. And what would happen to my domain? Well, it looks like the domain has been shrunk by 2. So it's going to be from 0 to 2. Okay, r of x. R of x, we take 1/2 of h prime of x, and we want to also shift that by 2, so plus 2. The domain of that goes from 0 to 6. And our final one, s of x, put a 1/2 in the front to compress it by 1/2, and that was k prime, and we have to add the 2 to shift it to the left, and our domain now goes from 0 to 10. Okay. Describe how you used what you know about transformation functions to determine your answers. Well, we know that A is a vertical compression. So we had to say A was equal to 1/2. C moves it right or left. So we needed C to equal the value of 2. Okay, they want to create some clouds on top. All right, and we're going to start with the function the negative cubed root of x plus 14. So we want to transform this function and write 2 more to create clouds that the students want and graph the results. Okay, you can create any that you want. I'm going to just shift this one down by 1. And then let's shift the next one by 2 from there. Okay, so let's see how we will write those. Let's call this one d of x. And if I've shifted it down by 1, so it's going to be 14 minus 1, so this is negative cubed root of x plus 13. And what should we call this one? A, B, C, D, E. E of x, I guess we'll call that one. It's still the negative cubed root of x, and I'm starting at 11, so that would be plus 11. And there are my extra clouds. Yours can be different, does not matter. And again, this is how we would transform a cubed root. Same things that we did with our square root. Remembering that A controls vertical compression or stretch, as well as reflection vertically. B controls our horizontal stretch or compression, as well as the reflections horizontally. C controls your right and left movement, and D controls the horizontal movement.